हेलो स्टूडेंट। आज हम आपको पीस वाइज फंक्शन में बताने जा रहे हैं ग्रेटेस्ट इंटीजर फंक्शन, लीस्ट इंटीजर फंक्शन और फ्रैक्शनल पार्ट ऑफ फंक्शन। ओके, so now I am going to share my screen to you and okay, see this. This is a blank page. Here I will write. Okay, so greatest integer function. Function denoted like this, square bracket. Okay, a square bracket. It is written like this. Why? It means, let's say, if you have given like this 2.2 this 3.12 greatest integer function minus 2.2. Okay, so this will come like this. It will come to whatever the integral part of this value 3, and this will come minus 3. Okay, because the lowest integer uh, for this value, little bit confusion, like minus 2.2. Okay, so before that, which integer come? Minus 3. Okay, if you are coming at a number line, see, it will be more clear on number line. Okay, 0, minus 1, minus 2, and minus 3. Okay, or this 2.2 is somewhere in between this. Okay, so this will be take like this. If some value between 1 and 0, then 0, like this. Okay, so I am showing plot to you. Again, going to the same app, and yeah, right here, y equal to greatest integer. Okay, let's see. Yeah, what happened to it? Y equal to this. No, no, okay. Then see, uh, it's look like this. This is x-axis. This is y-axis. Okay, whatever the value from this point. Okay, whatever the value till this point, whatever the value till this point, like this. Okay, and uh, similar for this. in the negative. Okay, I am plotting it. Plot, okay. Go to the function and this. It's also known as floor. Floor means it is taking the lowest value. See, this is look like this. Whatever I have drawn. Okay. Uh, Whatever at one it exists. This is the dot point. You can see in this. Okay. Uh, Value is here. For any value between 0 and 1, this. Any value uh, between 1 and 2. This 3 for any value between 3 and 4. 4 for any value same in the negative direction. -1 for any value between 0 and -1. -2 and like this. Okay, you can label it like this. Y-axis, Y dash, this is X. Okay, next slide. I'm talking about the domain and range of this function. I told you in simple word, domain, whatever at x-axis is domain and whatever is value is at y-axis is range. So domain is R. Okay, domain is R, or you can write like this: x belongs to R or x belongs to -infinity to +infinity. Range is only integer. You can denote integer with I. Sometimes it is denoted as Z. Okay. Okay. Then uh, there is some property of this function. What is this property? Uh, let's say function C. X is written like this: integral part of x plus fractional part of x. For example, let's say I have taken x equal to 2.3. So this value is, for this x is 2 and fractional part of x is 0.3. Okay. See, uh, x plus I, then it come out like this or this. Okay. Frac- For integer, for integer, fractional part is 0. Part is 0. Okay. So it is like this. Separately, its fractional part is 0, then it will come like this. Okay. See, another result you can see. These are not results, these are practical. You have to know, like, see, if you have given two values, x and y, x plus y, okay, so you have taken this function, so this value is greater than or equal to this. Okay, why? I'm taking example x equal to 4.6 and y equal to 3.7. Okay, then you add it x plus y equal to 3 and 8. It come out to be 83, 8.3. Okay, then you will take this greatest integer function to it. This come out to be 8. Okay, and separately you take x greatest integer is equal to 4 and y greatest integer equal to 3. Then this greatest integer of x and greatest integer of y equal to 7. So this inequality holds. When equality holds? When uh, sum of sum of integral parts, sum of the fractional part. Okay, when sum of fractional part is less than 1. Okay, part value is less than 1, or both are integer. Then inequality holds. Then this will be equal. Okay, like this. Okay, so you have to think why. You can put this is very basic thing. This is not very high-fi thing, but this you can think these are the some technical term or vocabulary of a mathematics. Okay, I have talked about the domain and range. Okay, then another property, uh, you can simply check it. Writing property is, I think I am coming on the another function. Okay, this function is fractional part of x. So this function is fractional part of x. It is written like this: uh, y equal to this. Okay, domain again r or minus infinity to plus infinity. Uh, range 0 to 1. Open interval at 1 because 1 will be not included. If it will be equal to 1, then its fractional part 0. Okay. See its graph. Okay. I will show the computer. Then I will show you this. Okay. See, this will be look like this. 0 and it will be go up to this. And there is a blank. Again, its value is 0 and integer. And then again this. Many you can draw. Same kind of line will reflect. Similarly, And one thing I want to say, fractional part is always positive. Fractional part is always positive. Why? Uh, because this is equal to fractional part equal to x x minus this. Okay, let's say fractional part. Let's say x equal to 3.3. Okay, so greatest integer of this function is 3. Put this fractional part is 0.3. Okay, again I am taking another function minus 4.2. Okay, greatest integer function of this is equal to minus 5. Okay, and put here fractional part x minus a. Then 4.2 minus 5 minus minus plus, it come out to be 0.8. Okay, so fractional part is always positive, always greater than 0, never negative, non-negative you can say, not positive but non-negative, which is because it is 0 for uh, integer value of x. So I have written here range. Range is this value. Whatever the value of x you will take, range will be this only. Okay. So I have plotted graph. I am trying it in the calculator. Okay. See, function. Function. Y equal to x minus instead of this, I have to take 4. Okay. I am reading this. So this is look like this. Okay. Whatever I have drawn here. Okay. Same thing. So today I have finished um, greatest integer function. Another function less commonly used, but it is also important. You should know. Uh, as b greatest integer function is also known as ceiling function. Okay, I am writing that. Greatest integer function. This is written like this. Okay, or somewhere written like this, as you have seen in Microsoft calculator. Okay, and fractional part of x is written like this. Fractional part of is written like this. And a list integer function, which is denoted like this. Yeah, this is not closed, like this open, or like this. Okay, so this function y equal to this list integer function equal to x plus list integer function is written like this. List integer function is written like this. If you are writing, then you have to take highest value of x. Let's say you have given 3.2. So then you have to take, if you are taking list integer function of this will become like 4. Okay. So this function is written like this: greatest integer function plus 1. If you are taking list integer of minus 2.2, okay, is equal to minus 2. Okay, this. So this is nothing. I'm again showing it in this, hiding it, or I'm writing here y equal to y equal to this function. This is ceiling, na? Ceiling x. So it will become like this. Or I am also showing y equal to uh, floor x. So you can see, if I will hide a floor x is when x value of x between 0 and 1, then value of function is between 0 and 1, then it says it is equal to 0. Value of function is between 2 and 1, then value is 1. Okay. Uh, this is for a greatest integer function. I am hiding it and going for this. When value of function is between 0 and 1, then value is 1. Okay. And I am hiding it and again going for the fractional part of x. So you can say between this, again this, whatever the value other than the integer, uh, the lowest value will be subtracted from it, whatever the integral value, and then it will be between minus 1. This is also periodic function. This period is 1. Okay. So this will be talked in the later lecture when I will take the function classes. Okay. So now I am going to stop my lecture here. This is all about the piecewise defined function. Okay. Thank you for watching this.